Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have discussed a stereochemical aspect of nucleophilic substitution reaction. Under that I have discussed optical activity, chirality. Now I am going to discuss retention. After that I will discuss inversion also. Three terms I will discuss: retention, inversion, racemization. Yesterday also I have given idea about racemic mixture. Yesterday last class I have discussed. Now I am going to discuss retention. Retention of configuration is the preservation of integrity of the spatial arrangement of bonds to an asymmetric center during a chemical reaction or transformation. What is the retention? And retention of configuration. Retention of configuration is the preservation of integrity of the spatial arrangement of bonds to an asymmetric center during a chemical reaction or transformation. It is also the configurational correlation when a chemical species like XCABC is converted into the chemical species YCABC. When a chemical species X, capital X, you can write XCABC, X and C. X may be halogen, C is carbon, again ABC may be the group. Okay. Then it is also the configurational correlation when a chemical species XCABC is converted into the chemical species YCABC having the same relative configuration. Means here carbon is in the center and small a, small b, small c is the different group. X is halogen group that can convert into other molecules. Then it will be again same things, only X will change to Y. On the carbon A, B, C will be there. In the place of X, Y will be there and other things will be the same. In general, if during a reaction no bond to the stereo center is broken, in general, if during a reaction no bond to the stereo center is broken, the product will have the same general configuration of groups around the stereo center as that of reactant. Here I told you A, B, C positions are same. Only X has changed to Y. Means maybe chloride may change to bromide, but positions are not changed. A, B, C, X, their configuration is same. Then in the new product, when transformation will take place, A, B, C position will be the same, means bond will be the same. X and C bond, that is also same. X and Y bond is the same like X and C bond. C is the central metal bond and X is halogen. Or halogen means X, maybe other group also. X now changed to Y. Then this is the only change, new product. In the reactant it was X, in product it became Y. but all things are same. Correct? Then this is actually a retention because all A, B, C positions are same, arrangement is same. Even X and C bond is same. There also Y and C bond is same, only molecule has X and Y has changed. Then in general, if during a reaction no bond to the stereo center means asymmetric, all are different. A, B, C, X, all four are different. That's why it is called asymmetric, also called stereo center. Then if during a reaction no bond to the stereo center is broken, the product will have the same general configuration of groups around the stereo center as that of reactant. Such a reaction is said to proceed with retention of configuration. Retention means what was in the beginning and the end also it will be like same way. Then such a reaction is said to proceed with retention of configuration. Now consider as an example the reaction that takes place when -2, minus means here what? Labo. Okay, minus means here, plus means dextro, minus means labo. Okay, means that light effect. Here optical property you are telling. Here minus means labo, and plus means dextro rotatory, labo rotatory. Okay, that compound will rotate the light either in right direction or left direction. Correct? Sometimes right direction it can reflect more, and this left direction can move less. Correct? Means suppose the right direction from the beginning 60 degrees turned, and sometimes it can rotate left direction also, now maybe 40 degree. But if both side it is just their light what is coming, if they are rotating in equal angle both side, left side and right side, then it is called racemic mixture. Process is called racemization. Then now here minus means laboratory. Then this example I am telling you for a retention. Okay, retention of configuration. Then here the reaction that takes place when 2-methyl butane 1, that is it is labo, optical, this is the optical isomer labo, means left, don't forget, L means labo, L means left. Then minus 2-methyl butane 1 all is heated with concentrated hydrochloric acid. Then it is actually butanol, and it is going to be heated. Then now this all molecules you can show by that symbol black and means dark black and dash. Okay, last class I have discussed. Then here 2 are above the paper, dark, 2 are above the paper, 2 group H and CH2, and 1 group is down the paper, means CH3, and ethyl group CH2 CH3 is on the paper, means here out of 4 H and CH2 are above the paper and 1 is means CH3 down the paper, and ethyl group CH2 CH3 it is on the paper, means total 4 groups are attached, one ethyl group, one methyl group, one H, another CH2, also called methylene group. Then now this is actually CH2OH group is actually attached. It is actually 2-methyl butane 1-all. Butane 1-all. Okay, butane means 4 carbon will be there. Then 4 carbons are there. But in the first carbon, a second carbon, methyl group is attached. Correct? Second carbon, methyl group is attached. And only from that carbon, CH2OH is there. Then now, this compound is heated in the presence of HCl. Then what will happen? That now this OH will be replaced by Cl. OH and H of HCl, both will form water. HOH means water, and Cl will replace, means X now exchanged with Y in general way. OH now replaced with Cl. Then now all structures are same. All structures are same, means HCH2, methyl and ethyl. Their arrangement has not changed. Arrangement has not changed in the product. That CH3 is down and H and CH2 is above the paper, and CH3 means ethyl is on the paper. Arrangement has not changed, means configuration has not changed. Even about this CH2OH, only OH changed. CH2 is the same. CH2 is attached with center carbon, second carbon. That also has not changed. Means four groups, their configuration has not changed. Only with CH2OH group was there, that gone, and new group came. OH went and Cl came. But main structure you can see, main 4 bonds, there is no change. CH3 has not changed, their position is same. And H and CH2 is not changed, it is above the paper. And ethyl group means CH2CH3 also is on the paper. Then it is actually a retention. Configuration is retained. Okay. Now I am telling you inversion. By name it is clear. Inversion. I given one example that in a storm, umbrella will just it will, you can say, invert. Means due to the you can say bend, that inside will go outside, opposite. Sometimes it happens. That is called inversion, invert, opposite. Okay. Then what is actually inversion, retention and racemization? Now this I have told about the retention. Now you just see the inversion. Okay. Actually these 3 terms, inversion, retention and racemization, you can understand by one reaction. Okay. Now example I am telling you. There are 3 outcomes for a reaction at an asymmetric carbon atom. Now again you take asymmetric, means 4 different groups. 4 different groups are attached to center. Okay. Attached tetrahedral, you can tell. And from the center, now consider one H is there, that is the towards down the paper. Methyl you consider above the paper, and X and C2H5 you consider on the paper. Total 4. First is CH3 above the paper, black, dark. Okay. And this H is down, dash, down. And C2H5 is on the paper. X is also on the paper. X I told you it is a replaceable. Then now suppose reaction takes place with Y, then now already I have told you that X will replace with Y. Then now a structure will not change. All things will be the same. Only X went, Y came, but bond, there is no change in bonds. All bonds are as it is. Means CH3 was above, now it is above the paper. H was down the paper, now again it is down the paper. C2H5 was on the paper, it is on the paper. X was on the paper, now Y is also on the paper. Only X changed to Y. Then this is the example of retention. Now same molecules. Now you can see other side what will happen. Same molecules. Sorry for disturbance. Now same molecules, just you see. Now suppose again this time one group is coming. Take same group like Y. Then in this situation other possibilities I am telling you what will happen. That now this C2H5 position will be as it is. Second possibility I am talking about. With Y only. Suppose it is reaction taking with Y. Then now you can see other possibilities. Opposite possibilities I am telling you. That now C2H5 position is the same, mean on the paper. And H position, Y position, CH3, all three changed. All these three position of these three group except ethyl group, all three groups position is changed. Position changed means where CH3 was there, direction of CH3 just it reversed. It was right direction, now it became left direction. Above the paper it was right towards right, now it became towards left. And X was towards left, now it went towards right. And Y was it was down, but it was right direction. Now again it is down but left direction. Means here all things reversed except ethyl group, all three group just became opposite. Okay, that again I am telling you, methyl group was above the paper but it was right direction. Now after the reaction it is again one say upside, but direction changed. Now from the right it became left, and X was left side, now it became after the reaction right, and H was down, now again it is down only, but it was in the beginning right direction, now it became left direction. Then see, all they change the position towards opposite. Atom wise they have changed, atom wise it changed, or molecule wise changed the position, means it reversed, it went to opposite. Correct? Then here from the one molecule what I discussed, that two possibilities I told you. Then now you can say first possibility is that you can tell A possibilities, and second possibility you can tell B possibilities. Correct? And now if you can say this will react, third possibility is I am telling you, third possibility is that now what will happen, what we got A plus B, A and B if you will add, then that will be the A and B if you will add, that will be the third possibility, correct. You will get together, A will also get, B will also get. This is the first you thought that it will give only A, and second you thought it will give only B, but third possibility is that you will get both A and B, both A plus B you will get. Then if A is the only compound obtained, the process is called retention of configuration. If you will get only one compound, if you are getting A is the only one compound obtained, the process is called retention of configuration. Okay, because nothing has changed, only that X changed with Y. Now if B is the only compound obtained, the process is called inversion of configuration. First was retention of configuration, means same things you got. Structure was same, all group direction was same. But if B is the only compound obtained, the process is called inversion of configuration. Why? Because all molecules went to the opposite. Except which was on paper, that have not changed, but other three, that position is same position. Ethyl group position was changed on the paper, other has changed. Then it is called that is the inversion, because their position just inverted, all group inverted, angle changed, all group, as for example H, Y, CH3, all changed except ethyl C2H5. Then this is called inversion of configuration. It inverted, went opposite. And if a 50-50 mixture of the two is obtained, 50-50 mixture of the above two is obtained, then the process is called racemization, and the product is optically inactive. If both are 50-50, then you know that one is negative, other is positive. Then 50-50 means it will be inactive. One actually in the beginning of only right. If only in the right, then dextrorotatory. If only left, then laboratory, L. And now suppose both are 50-50 are present, 50-50 both products, then that will be racemic. Okay, that is called racemization, and the product is optically inactive, no active, inactive as it is, no active, inactive. Then if a 50-50 mixture of the above two is obtained, then the process is called racemization, and the product is optically inactive, as one isomer will rotate light in the direction opposite to another. Why it will be inactive? Then I am telling you, as one isomer will rotate the light, okay, in the direction opposite to another. Hence finally it will be inactive. Then now I have discussed 3 terms. Okay, I think now you have understood. Again further I am telling you, now just you consider. Now let us have a fresh look at SN1 and SN2 mechanism by taking example of optically active alkyl halide. Okay, take again example, just a fresh look of SN1 and SN2 mechanism, taking example of optically active alkyl halide, optically active alkyl halide. Now SN1 and SN2, now so you are understanding very clearly. One means first order reaction, and it will be 2 step, and second order, SN2 means second order, but only 1 step, correct, opposite to each other. Then now this again you understand, fresh look you can tell at SN1 and SN2 mechanism by taking example of optically active alkyl halide. In case of optically active alkyl halide, the product formed as a result of SN2 mechanism. SN2 mechanism means only 1 step, but depends upon 2 concentration, correct. In case of optically active alkyl halide, the product formed as a result of SN2 mechanism has the inverted configuration as compared to the reactant, correct. Means SN2 is the example of SN2 mechanism, now is the example of inversion of configuration, correct. Always remember, same molecule means this ethyl halide, you can know ethyl chloride as for example you can take, or in general alkyl halide. Then that alkyl halide that will tell SN2 mechanism, and it will invert, it will be inverted, or you will get inverted configuration. Means all group will change the position, means it will invert, opposite way it will go. Okay, now this why did it happen? Already I told you, this is because the nucleophile attaches itself on side opposite to the one where the halogen atom is present. Where halogen atom is present, there from opposite direction it will attack or it will attach, correct. Then why change the inverted? That reason I am telling you, because the nucleophile attaches itself on the side opposite to one where the halogen atom is present. And now come to the LAVO, negative. Now take example of 2-bromo-octane minus LAVO. When minus means LAVO, 2-bromo-octane is allowed to react with sodium hydroxide. Now SN1, I am coming towards SN1. When the 2-bromo-octane, which is a LAVO, negative, L, small l, is allowed to react with sodium hydroxide, means OH group is there. Then what will happen? When 2-bromo-octane is allowed to react with sodium hydroxide, plus octane 2-ol is formed. Now we will get plus octane 2-ol is formed with OH group occupying the position opposite to what bromide had occupied. Here, now example I am telling you of bromo-octane, means phenyl group is attached, C6H13, that is the phenyl group, benzene ring, correct? C is benzyl group, you can tell, one H is removed, C6H12 was there, you know that in this phenyl group C6H13, now you understand, okay, that C6H13 is attached, that is one group, you understand. Other group is in the middle, carbon is there, after that one methyl group is there, then now it became 6H13, that is one group, and that is attached with central carbon, not seventh. From that one methyl group is attached, total 8, and from the center one H is there, one Br is there, both are opposite direction. H is down, you can tell, real direction is down, and C6H13 is above the paper, H is down the paper, and CH3 and Br is on the paper, but they are in different angle. Then now this Br is reacting with NOH, then OH will now replace with Br, okay, but it will attack from the backside, means where direction of bromine was there, just opposite, OH will attach, and Br negative will, bromide ion will leave. Then this I have told you about the SN2 reaction of optically active, because direction has changed. Thus SN2 reactions of optically active halides are accompanied by inversion of configuration. Inversion because direction has changed. If you will see, then you will find now that C6H13, which was on the left direction, now it became right direction in the product, and CH3, which was on the paper left direction, now it became right direction, correct, and Br, which was in the front, now it replaced with OH, that changed the opposite, it went to the opposite, and H also just change the opposite position. Both Br and H both change the position. Br, what was the position? Just opposite it went, and H, what was it? Was down only, but it was left direction. Now again it is a down, but right direction. Then this you tell that SN2 reaction of optically active halides are accompanied by inversion of configuration. These two example I have told you of SN2 reactions of optically active halides are accompanied by inversion of configuration. Okay, now come to the SN1. Okay, two example I told you. Now I will tell about the SN1 mechanism. In case of optically active alkyl halide, again it is a alkyl halide only, active alkyl halide, optically active. You are taking again same example, optically active alkyl halide. Now here you can understand SN1 reaction. SN1 reactions are accompanied by racemization. Racemization means it will become inactive. Racemization means inactive. Okay. In case of optically active alkyl halide, SN1 reactions are accompanied by racemization. Why? Then now you can understand. Actually, why it is racemization, that I am telling you reason. Actually, the carbocation, you know that in SN1 carbocation is formed in one step, and in second step nucleophile will attack. In both cases, SN2 or in SN1, in both cases OH, nucleophile will attack in general way. OH minus you can tell. Okay, example of nucleophile. Then in both cases, OH is going to attack. But in SN2 cases, only in one step reaction takes place. Then that is the SN2. But in SN1 first carbocation will be created in one step, and then nucleophile will attack. But in the first case, SN2, direct it was attaching to carbon. Okay, means both in the presence of the original chloride, as a fifth one, Nu was attaching. Correct? And same time it was, original was trying to leave. That was actually a transition state. Quickly it will leave and Nu will join. But here I am telling you, in SN1, first carbocation will be formed and then nucleophile will attack in second step. Means here no intermediate. In SN2, no intermediate. But in SN1, intermediate formation is there. Means carbocation is formed. Okay. Then now I told you that here actually the carbocation formed in the slow step. Slow step is the rate determining step. Don't forget. Then here the carbocation formed in the slow step being sp2 hybridized. sp2 hybridized and is a chiral. Okay, a chiral, or it will be in a planar. Correct? Then the attack of the nucleophile may be accomplished from either side, from both sides, either side, resulting in a mixture of products, one having the same configuration, means OH is attached. Correct? The OH attaching on the same position as halide, and the other product having opposite configuration, means the OH attaching on the side opposite to halide ion. Then see, then plus 50% right, 50 means rotation is 50% right, 50% left. Okay, both product are formed. Labor product also and dextro product also. Both products are forming, hence both are neutralizing. Okay, that's why it is becoming both optically active, plus or minus both are same. That's why it is becoming neutral. Okay, then this I told you, one is in the same direction where original halide was there OH attached, and in the second case opposite, where halide was there, opposite to that nucleophile attached. Correct? Then this I told you, and by hydrolysis of optically active bromobutane. Actually this example you can understand by optically active 2-bromobutane. You take example of 2-bromobutane. It was actually optically active, or you tell it is optically active. 2-bromobutane, 4 carbons will be there. Then one is in the center and one is ethyl group. In that 2 carbon is there. One is methyl group. Then 3, one is hydrogen. One ethyl group. One group is ethyl group. Means 1 carbon is over. One group is over. Second is methyl group. And third is H. And fourth was H. Fourth was actually this halide was there, that is replaced. Then it created positive charge on the carbon. Suppose it was Cl. Then Cl, when it will, Cl will go as a Cl minus, that on carbon it will be positive, and carbocation will be formed. Carbocation is formed. Leaving the group means carbocation is formed. One step is over. And in the second step, two possibilities are there. That it can join, nucleophile can join in the same direction, where actually this was attached halide, in the same way, only in that direction it will join, it can join. That is the one possibility, correct? Then suppose it was in the right direction, Cl was attached to the right, then now OH will go to the right only, and it will form that OH. Cl will go from where Cl went, there only that position only, in the same direction OH is attached. Now it became, product became same way, CH3, CH is there, H is there, methyl group is there. But only difference is that OH position has not changed. What was the Cl position? Same is the OH position. But this groups their position just changed. That it came to the opposite. All three group you can tell now their position changed. It became opposite. It became opposite like that way. Okay, means their position changed. Then it is now it is forming butane 2-ol. Butane 2-ol negative. This is the labo. Okay, means rotation was left direction. Okay, and now other possibilities that OH will join from the back side, opposite to the Cl, where it was there, opposite to that. Then now other you can say position will be, other position means C, other group position will be again change. Okay, here position will, CH3 position will change, means all three position will, means position will change, not to all but two will, the here H position will change, methyl position will change, but change will be there. But this is the plus butane 2-ol, both are left side also butane 2-ol, right side also butane 2-ol, but that molecule rotated light to the left. Now this time this butane 2-ol rotated the light towards right plus. Then both are angles are equals. Then this is actually called, process is called racemization. Okay, and if you can say angles are same, then both will be cancelled. Okay, then in that situation it will form you can say racemization. Actually this is called racemization. Two are L and minus and plus, or L or D, whenever both will form, then process will be racemization. And when both their angles are same, then it will be optically inactive. If angles are same, right side and left side, then optically inactive. Okay, but always it is not necessary. But racemization can take place if both forms are, both L and D both are forming, then it is called racemization. Now I am telling you about the elimination reaction. What is elimination reaction? This is the common reaction. Elimination reaction means other properties I am talking about of haloalkane and haloarene, other properties. Okay, Elimination means here during the elimination, only in the beginning I want to tell you, during the elimination some molecule, particularly H2O, in general way H2O will come out. Sometimes HCl will come out. HCl, HBr, HI will come out from the molecule. That's why it is called elimination, eliminated. Okay, molecules will be eliminated. And now this is the main things of elimination reaction. When a haloalkane with a beta hydrogen atom is heated with a alcoholic solution of KOH, alcoholic solution means KOH is dissolved in alcohol, there is a elimination of hydrogen atom from beta carbon and a halogen atom from alpha carbon atom. Means this hydrogen from beta carbon and halogen from alpha carbon. Hydrogen from one carbon, that is beta carbon, I will tell you beta and alpha carbon. Then from the one carbon hydrogen is going out, and from the other carbon halogen is going, means Cl, as for example, means HCl is going outside. Okay, HCl is going outside. Then now this when haloalkanes with beta hydrogen atom is heated with alcoholic solution of potassium hydroxide, there is elimination of hydrogen atom from beta carbon and a halogen atom from the alpha carbon. As a result, an alkene is formed as a product. Why? Because when H will go as a H plus, then leaving the electron it will go, that carbon will have negative charge, negative, and other Cl is going out. The Cl will leave by taking the electron. Hence that carbon will have positive charge. From where chlorine is going, it will go with electron, a pair of electron. Then that carbon will lack one pair of electrons, positive charge. And when hydrogen gone, then it went without electron. Then that carbon will have positive. It will have 2 electron. Then now see, one carbon has 2 electron, other carbon is lagging 2 electrons. Then one bond, for one bond 2 electrons is required to make one bond. Then now one carbon is positive, other carbon is negative. Correct? Means from the carbon from which hydrogen gone, that is a negative. Carbon anion you can tell. But now one bond is there between both carbon. And now other carbon plus charge is there, and both will make one bond, because 2 electrons will be given by carbon from where H has gone. Okay, then now positive carbon, negative carbon, bond will be formed. It will come double bond. It will form double bond. Then here now understand the meaning of alpha and beta carbon. Okay, means suppose 2 carbons are there. Then one carbon is alpha carbon. First carbon will be called alpha carbon. Second carbon will be called beta carbon. Continuous 2 carbon. That is called alpha and beta. Then now from the one carbon H is going, and for the other carbon X, means halide is leaving. Okay. Then that HX will go, means HX will go. Finally HX will go. But this will, how it will happen? By own it will not go. This H and X by own it will not go. Some reagent should be there to make the both bond weaken. someone should be there. Why simply this bond will break? How it will break? No question. Then here, who is weakening the bond and compressing them, that leaving that hydrogen? Who is, you can say, doing all the things? Then it is base, NOH. Okay. KOH, I told them that alcoholic KOH, that they are compelling them to, making it, you can say, compulsion to live. This KOH is making them to live. Then KOH, that is the base. OH is base. Then that base, actually, just like how you can tell that someone will attract you by giving something. Okay, here, now tell, why you are working here? I will give more salary. Then what you will do? People will generally change the company. Like same way, hydrogen was attached with carbon, because carbon was giving hydrogen. Carbon was giving electron. That's why hydrogen was there. Now this base is there. Base is having electron. Now I will tell you more electron. Okay. Base will have electron. It can give the electron. That's why H, that bond, carbon and H bond became, you can say, weak. And finally it broken also. And it made bond with BH, base. OH was there, then OH and this H. It will make bond. Okay. Then like suppose OH was there, H went. It can form water. Correct? Whatever B you can tell, B means base. Then base will give the electron to H. Then that bond H, C and H bond will break, and new bond B and H will form. And when this bond is formed, then what will it do? This C and Cl bond was there, that will automatically, it will break. Because now that H went leaving the electron. Then here what will happen? X will leave. X will leave by taking the electron. And what H has left, that electrons, 2 electrons used up in making the bond. Then carbon, one was the original, now one more bond formed, double bond. Okay. Then this I have told, that is the one example of elimination reaction. Correct? Actually it will finally HX will, NOH will be agited, and this B will be separate, and H and X will form HX, and it will go finally. But here how it left, I told you. Okay, it will leave HX in the form of HX, like a ClHbRHI. It will go. Sometimes it will go as a water molecules also. If there is a possibility of formation of more than one alkene, if there is a possibility of formation of more than one alkene due to the availability of more than one beta hydrogen, means beta carbon, suppose now 2 hydrogen is there, then you can say now 1 hydrogen means 2 electron, then 2 hydrogen means 4 electron it can get. Then if there is a possibility of formation of more than one alkene due to the availability of more than one beta hydrogen atoms, usually one alkene is formed as major product. If there are 2 hydrogen atoms, beta hydrogen, then one will be major product, alkene will be major product. Out of 2 product, one will be major. Okay, one alkene is formed as the major product. These form part of a pattern first observed by one chemist was there, Russian chemist, that is the Alexander. Okay, these form major part I am talking about. These form part of a pattern first observed by Russian chemist Alexander. Okay, also pronounced as Alexander Satyjev, you can tell, Saytzeff, Satyjev, Sayt, Satyjev, Zeff, and he got in 1875 just one rule he formed, which can be summarized as a dehydrogenation. Dehydrohalogenation. Halogenation I am talking about. D means living. Dehydrohalogenation. Dehydrohalogenation reaction. Because hydrohalogenation I am talking, not only halogen. Hydrohalogenation, HCl, HBr, HI, like that way. That is called dehydrohalogenation. Only halogenation is different. Only living Cl, Br, I, but HCl, HBr, HI. This is actually hydrohalogen. That's why it is called dehydrohalogenation, leaving the HCl, HBr, HI. The preferred product is that alkene which has the greater number of alkyl group attached to the doubly bonded carbon atom. This is the condition. Preferred product. Which will be the preferred? The preferred product is that alkene which has the greater number of alkyl group, means CH3, attached to the doubly bonded carbon atom. Example I am telling you, 2-bromopentane. 2-bromopentane gives pent-2-ene. It will give pent-2-ene as the major product. Then 2-bromopentane, you know that here carbon number 2 bromine will be there. Total 5 carbons are there. In the beginning CH3 and the end CH3 is there. Then Br is attached to the second carbon. Then that is the beta carbon. Then now here what will happen, that actually in this beta carbon 3 hydrogens are there, CH3. Then now that from the beta carbon bromine is there, then this from the alpha carbon 1 hydrogen and Br is there on second carbon. Then it will H and it will go. H will go leaving the electron, and Br will go by taking the electron. Hence double bond will be formed. Okay, this is the pent-1-ene. First and second carbon, you can tell between that is the pent-1-ene. This reaction will take place in the presence of base OH. Okay, OH minus you can tell. But this product pent-1 is only 19%. Only 19%. Okay, minor product. But major product is what? That is the bromine was in second. Then just now adjacent carbon, means third carbon, that hydrogen, if it is living with bromine, then there also it can form the double bond. Okay, can form the double bond. Then now this is a pent-2-ene. Product is the pent-2-ene. Total 5 carbons are there. At carbon number 2, double bond is there. 2 and between 2 and 3. That, but it's now it is 81%. 81%. Okay. Then here you can see it is 81%. This is the major product. Okay. It is the major product 81, pentane-2-ene. Then this I have discussed about the elimination reaction. Now I am stopping only here. Next class other properties I will discuss. Thank you.